Hello everyone, welcome to my channel ETL Hub. In this session, we will try to learn how to process API data using data integration services. We will try to cover following topics starting from creation of Swagger file in a series until we create the final framework for pagination mechanism. So this entire process will be divided into two videos. In the first part, we will try to cover all the topics marked in red from creation of Swagger file till loading the API data into main table. And in the second part, as a continuation, we will learn about pagination concept and apply the logics to create the ETL framework for pagination mechanism. I will request you to go through all the videos from end to end and go through it thoroughly. Try to practice it alongside. So this will help you to cover all the topics and be confident with it. You might be having a question in the series of application integration why we are going to learn about loading the data using data integration services. So there will be scenarios where you need to load bulk data from API. So when you compare this with your application integration, the processing of bulk data through API is much faster than the process in CI, that is application integration. The another catch is like the response size up to 5 MB, CI can easily process it, but anything about 5 MB, it will throw an error. So like when there is a bulk data coming from API, definitely the size exceeds. Writing pagination logic and maintaining code is also simple in data integration when compared to application integration. You can also do the scheduling of jobs to load the data from API to data warehouse. Let's start writing ETL in IICS to fetch the API data into our database in 4 steps. In step 1, first we will create the Swagger file from the API request. Then we will go to the step 2, create the REST v2 connector referring to the Swagger file. In step 3, we will create a business service component which will create a connection with the REST v2. And in the step 4, we will write the mapping using web service transformation and fetch the response from the API and then store into our database. Let's specify the Swagger file details. I will give the name of the Swagger file as Pokemon underscore API. Select the runtime environment. Let's give the secure agent as the runtime environment. As we are using get method, the verb will be get. We don't have any authentication type. Generally, it might be basic, digest or OAuth, but we don't have any authentication type. So we are giving it none over here. So accept and content type will be application JSON. So we are sending the request in JSON format and accepting the response in the JSON format. So both we have kept as JSON. Now let's try giving the URL. If you split the endpoint till pokeapi.co, this forms my URL, base URL. So in the URL section, give this as a URL value. We don't have any API base path. We have API path as API v2 Pokemon. Following are my query params. It is in value key value pair. So we have offset and its respective value separated by another query param, limit and its value. Give the operation ID. This is the must field. Click on save. If there are any issues, it will throw an error and Swagger file will not be created. So it is showing endpoint has returned non-successful or invalid response and error code is 403. So what I observed over here is like this particular secure agent might have no access to this URL. So we will use the user agent provided by Postman. So give this additional property in the header section and now try to save the request. Once it is successfully created, the Swagger file gets saved and it will show all the details over here. Click on this close option. You can see this Pokemon API Swagger file been created, and this is the JSON file. Now click on this download option. So here are the details in the Swagger file. So this is the host name pokeapi.co. Base path is null. This is my API path pointing to the Pokemon API. So this is the tag Pokemon API, the operation ID which we have given. So produce and consume will be in JSON format. Get is the verb, that is the method that we are using to fetch the data. So the parameters that we have offset and limit, we have details about it. So in operator is query, that means we are passing the params in the query param format, and the type is number, format is int 32. So this will be the values in integers, and in the header section we are passing user agent as the key, and this will be in the headers. So whenever the in value is in headers, we will be passing value in the request head. When the response is 200, so as you can see, when we try to send the request and when we receive the response as 200, which is successful, so it gives the description as successful operation and it creates the response schema. So here you can see the properties. So we have the count field, next field, previous field, then results, and also the array of results. So we have the name and URL. From here we will fetch the data for our Pokemon. That is the Pokemon name and its respective URL. After you download the Swagger file, paste this file, the Informatica agent server location. After successfully placing the Swagger file at the desired location, we will go to the step 2 and create REST v2 connector. So what is the REST v2 connector? It is used to create connection with web service applications built on REST architecture. So you can use it in source or target transformation, or you can use it in midstream using web service transformation. It supports Swagger specification 2.0 and OpenAPI 3.0. You can make single or multiple requests to the web service application and process the response data. So to create a REST v2 connector, as we are using a free trial version, we do not get it as a connector in the package. So we need to go to the add-on connector and take the free trial of 30 days for this REST v2 connector. So search with REST v2. So I have already taken the license for 1 month. So you will get similarly start free trial option on this connector. Click on those option and click OK. So once the REST v2 connector you get the license, it will be available for next 30 days and the connector will be ready within few minutes. Now let's create the connection. Go to the connections tab, click on the new connections, give the connection name, select the type as REST v2, select the runtime environment as your secure agent, keep the authentication as standard. We don't require any of these fields as we are getting all the details through the Swagger file. So we will just give the Swagger file path, give the exact Swagger file path, test the connection. It should be successful. The connection is successful. Save the connection. After successfully creating the connection, go to the data integration services. Now we will follow the step 3 to create the business service component. Click on the new, click on the component. Here we will go to this business services. So we need this component because we need to have the web service transformation, and we will invoke this component within this web service transformation. So click on the create, name it, click on the REST v2 connections available. So this was the REST v2 connector that we created. Select on operations, click on select. So we have only one operation ID that we during Swagger file creation we created this operation ID with this name Pokemon API. Select this, click on select. So the following operation is created. Click on the configure. So you can see three panels: request, response, and fault. So in the request, we will try to pass the values of offset, limit, and user agent through the mapping. And when the request is successful, so you have response 200. Within that, you have that count, next, and previous values that you will try to fetch. And in the result array, and within the result, we will have the name of the Pokemon and URL. We will try to fetch those two records and store into our uh, main table. Here you will get the response header values, and here you will get the response cookie. Third one is the fault. So if there are any issues, like if you receive any HTTP error, so you can, this is the by default fields created by IICS. It will create the request XML, error code, and also the error message. Click on save. Before started to get creating with mapping, let's create the table structure. We will create two tables in our Oracle database. One is the Pokemon table, which will store the name of the API, the Pokemon, capture the response from the API, and its respective Pokemon URL. And in the another table, page control table, we will store the page control details like limit value, offset value, count, and the next link value. So let's create the table first. Tables are successfully created. I will go to this page control table and initialize the entry. So click on plus sign over here. I will keep the limit, the page size as 100. Initial offset will be 0 as we want to fetch the data from first record. Count will be 0 and next link will be null. So click on the commit. This is the record that we have created. Make sure you have created connection for Oracle into IICS. If not, we can still create the connection. Go to the administrator, click on this connections tab, go to new connection, give the connection name, click on type as Oracle, select your runtime environment, give the username password. So if you are not sure about it, what are the properties, go to the Oracle, right click on this database and search for properties. So you can copy paste this host name and other stuff. Click on test connection. Connection is successful. Now save it. As we have created connection as well as required tables, let's get started with creation of mapping. Go to the data integration services. Click on new. Go to the mapping. Click on create. Name the mapping. Click on the source. Click on the Oracle connection that we created just now. Select the object as page control table. So as we want the offset values as well as the limit value that we will be sending to the web service transformation as a request. So we will make sure we are taking this table as a source. Drag expression transformation between source and target. So as we are going to use the runtime environment of the Postman, so we need to pass the header value to use the user agent of the run of the Postman. Click on the configure, put down the hard-coded value. Validation is successful. Also make sure to avoid any name field conflicts in the next transformation. So we will rename all the fields with the prefix in underscore. Now save the changes. Now drag the web service transformation between expression and target. Go to this web service in the properties. Select the business service component. So we have created one business service component, right? So choose that one. Use the operation ID Pokemon API. In the request structure, so these are the values which we are gonna pass to the API. That is offset limit, which are query params, and user agent is the param which is going to the headers. So map the values. So here in the response structure, you can see the root, and within root we have response to 100. When the response is successful, you will get the response headers as well and response cookies. So within the response 200, you have that count, next, and previous value, and also the result array. And within that result array, you have results where you have 0 to many mapping for that array, and you have that Pokemon name and URL. Click on this option to map all the descendants. So we have three groups: fault group, root, and results. So this is the by default group created by IICS to capture any error codes like HTTP errors. So in the root we have count, next, and previous. That is part of response 200, as well as we have response header and cookies. It will capture the response header values and cookies separately into this uh, field name. And in the results we have name and URL. So this is how it has converted the structured of response API into the web service transformation. So this count and next and previous comes under root, and our main values name and URL, which we are gonna pass into Pokemon table, comes under results array. Go to the output field mappings. In the results, make it 510 precision for the URL. So as we have defined it as a 510 in our database, make sure both are in sync. So if the URL is greater than 255 and you keep the precision as 255, the remaining characters will be truncated before loading into the table. So ensure that all the database data types and the precision at the output fields are matching to avoid any truncation of the characters. Link the web service to this target. So you will get three groups: fault group, root, and result. So we want to feed the name and URL into our main table. Click on the results. Go to the target. Create the connection with the Oracle Pokemon connection name. Select the object. Give your object name as Pokemon table. Now go to the field mapping. Map the fields. Save the changes. Mapping is valid. Rename this target name as TGT target Pokemon table. Save it. Now run the mapping. You can see now 100 rows has been processed successfully. Go to the Oracle. Just refresh this table, Pokemon table. You can see like there are 100 records inserted in this table. Its name and its URL as well. You can see the data is matching for the first request. Thanks for watching this video. Please do like and subscribe my channel. For part 2, where we will try to learn pagination concepts on top of the mappings that we prepared in this part 1, please follow the part 2 video in the series. Thank you once again.